Hi everyone, it's Miss Frankie. I'm going to be talking about 2.9, which is multi-step word problems. So yay, more word problems for the kids to do. I know these can always be tricky, but one of the ways that we like to show them is by drawing pictures and using grids. It's the best way to visualize a problem and easy for kids to see what they're actually doing. So, for example, I have this first problem here. It says Miss Frankie and Mrs. Hasenauer are setting up for a Halloween party. They set up 4 rows of 18 chairs in each row. They leave a chair at each end empty for trash. How many chairs are there for students? So, what we would tell the kids to do is to draw a picture. To draw the picture, we want them to do an array. So I'm going to draw 4 rows. So I'm going to go down 4 and 18 chairs. So 4 rows and then with 18 chairs going across. Okay, so I have my 4 rows. So I'm going to write my 4 rows of 18 total chairs. Now there is a little problem in this where we're not trying to figure out how many total chairs there are. I'm trying to figure out how many chairs there are for students. So there's this part in here that says that they leave a chair at each end empty for trash. So at each end of the rows, they're leaving these chairs empty. Well, there's 2 ways that we have talked about to solve this math problem. We know that the ends of each of these rows are going to be empty, so there's not going to be any seats. So I can either say, I can multiply 18 times 4, which gave me the total number of chairs. And then from there, I'm going to subtract from that 4 times 1 plus 4 times 1, because both sides are 4 times 1. Okay, well, 4 times 1 plus 4 times 1 would be minus 8. So to figure out 18 times 4, I can do it several ways. I would use probably partial products. So I'm going to take 4 times 8, which is 32, and 4 times 10, which is 40. And when I add them all up, I get 72. So now I have 72 total chairs. So that's 18 times 4 is my total chairs. It's 4 rows of 18 chairs. Well, I don't want to know how many total chairs there are. I want to know how many there are for the students. So I'm going to subtract from that the 8 chairs that are being used for trash. So 72 minus 8 is going to equal 64 chairs. Now, some of the kids have figured out that there is another way to do this math problem. They know that these 4 at the end are being taken away from the rows. So they've decided they're going to take 18 minus 2. That's because, if I think about this, I'm just taking 2 chairs away from the 4 rows on each side. So now I'm going to take 4 times 16. When I take 4 times 16, I will end up with 64 chairs. That again is 4 times 6, which is 24. Oops, I'm writing over a word here, our number here. 4 times 6 is 24, and 4 times 10 is 40, and when I add them up, I get 64. So that's one of the types of problems that they may be seeing here soon. The other type of problem involves kind of just drawing a picture. This one says Mrs. Russo places 5 gooey eyeballs into 12 baskets. If 2 of her friends do the same, how many eyeballs will there be in all when they are done? So I start with saying Mrs. Russo put those 5 eyeballs into the baskets. Okay, so I'm going to draw out 12 different baskets, and each of those baskets are going to contain 5 eyeballs. So what we decided to do is to draw those 5 baskets and then just put 5 in each, or 12 baskets, sorry, and put 5 in each of the baskets. I didn't want to spend time drawing the picture of each of the eyeballs. They could put dots. They could put anything. It's just to try to see it all in front of them. So this is what Mrs. Russo did. So I'm going to put Mrs. R down here. So she put 5 in each of the 12. So that's going to be 12 baskets times 5 eyeballs. Well, 12 times 5 is 60. So in all she has put 60 eyeballs. But does the question ask if Mrs. Russo did? We want to know how many will there be in all. We know that her 2 friends did the exact same thing. So if another friend put 5 eyeballs into the 12 baskets, that's going to be 60, another 60, and then if I do it again, another 60. Or I could say 60 times 3. And remembering from past lessons, I take the base problem, 6 times 3, which is 18, and add a 0. So there would be 180 eyeballs in the baskets when they were finished. There will be a part 2 to show you how to do some inside grid work tomorrow, so be on the lookout for that. If you have any questions, let us know. Thanks a lot. Bye.